All right, we're looking at more examples of differentiation, this time with respect to the indicated variable. So here we're differentiating with respect to t. So that left side is just going to be dh dt, and the right side is going to be 12t plus 3. So this one's our typical explicit differentiation. On this side, though, now we're going to differentiate with respect to w. So z is defined in terms of w. So I'm going to use chain rule. That's going to be 3z squared times derivative of z with respect to w equals differentiating with respect to w is going to be 4w plus 1. Now I could keep going with this and isolate my derivative. So dz dw is going to be 4w plus 1 divided by 3z squared. Oops. And then I could take that a step further and actually replace z in terms of w. So from this, I can see that z is going to be the cube root of 2w squared plus w. So knowing this, I could have taken my derivative from the beginning with an explicit equation. So this is going to be 4w plus 1 over 3 cube root of 2w squared plus w, whole quantity squared from this. So if I went ahead and took the derivative of this explicitly, then we would have dz dw is 1/3 of 2w squared plus w to the negative 2/3 times the derivative of the inside, which is 4w plus 1. Rearranging, this has an exponent of 2/3. The negative is what puts it in the denominator. There's my 3 to match. Here's my numerator. So in this case, I could differentiate implicitly or explicitly. That's not always going to be the case, though. However, for all of these, well, let's look at this one. If I wanted to isolate y here, I couldn't do it. So this one I need to differentiate differentiate implicitly. So this is going to be 4y cubed dy dx plus 2 dy dx equals 3x squared. Now I can isolate my dy dx by factoring, and I'll get 3x squared divided by 4y cubed plus 2. And again, in this case, I can't go back and replace my y because finding y explicitly is really difficult. This case here, I can use product rule. So that's going to be 1y plus x dy dx equals derivative of 6 with respect to x is 0. So now dy dx, dy dx is going to be negative y divided by x. And then I could go ahead and substitute for the y as 6 over x. So I'll get negative 6 over x squared. Notice if I had done this explicitly, y would be equal to 6 over x. Derivative of that, same thing.